In this video, I will show you how to find the MAC address of your computer or any other computer, and also how to analyze this information, or how to capture and analyze Ethernet headers and ARP frames. So the first thing I will do here, I start PowerShell, Windows PowerShell, or command prompt if you want. I start it as administrator. Uh, this is important for a reason that I will say later. First, I would like to display my ARP cache. I type ARP-A, and this is what ARP cache displays. In fact, one entry, and in this entry we have the IP address. So this is the IP address of my default gateway, and this is the MAC address of default gateway here. So you see, first column contains the internet addresses or IP address. Second column contains the physical addresses, MAC address or MAC address, and the third column is the type of entry. So this entry is dynamic. It means that if it's not used after some time, it will be flushed from the ARP cache. You can make the entry static, so you can dig into this information how to make it static, but for now I can redisplay the ARP cache. If I want to delete, I can delete the ARP cache, so that's why I have to run the Windows PowerShell as administrator, because if you are not administrator and you execute this command, it will ask you to elevate. It needs some privilege, so that's why I'm running Windows PowerShell as administrator. Now I am cleaning my ARP cache. If I display it now, you see there is no ARP entries found. There is no information. Now what I do, I come back again and ping the same IP address, which happens to be my default gateway, 192.168.100.1. Okay, I stop ping here, and then I display the ARP cache. So which means that next time my computer wants to talk to the same IP address, it's going to come here, get the MAC address. This is the MAC address that my computer will get in order to communicate with the machine with this IP address, having this IP address. So what I do something very simple. I'm going to use Wireshark, start capture, options. I will choose my network interface card, and here in the display filter I will specify only ARP. I want to display only ARP frames. Again, yeah, there are some ARP frames which are being exchanged. Okay, what I do, I'm going to clear the ARP cache first. I need to clear the ARP cache, restart the capture, and then ping. See? So the first thing that you notice here is that my computer is asking who has 192.168.100.1. Because ARP cache was empty, my computer does not have the MAC address of 192.168.100.1 in the ARP cache. So that's why it's sending this ARP request. And what you notice here, if you open the ARP resolution protocol request, you find that it has fields like hardware type, so it's used on Ethernet network, protocol type, IP address, hardware size, protocol size, opcode. Opcode is one, which means request, ARP request. This is the sender MAC address of my computer. This is the sender IP address or MAC address of my computer also. This is the target MAC address, which is of the target. This target MAC address, and you see all zeros because it is unknown at this time. And this is the target IP address because it is also actually this is the IP address with which I'm communicating. So all information are available except the target MAC address. This is the purpose of sending ARP request, to get the target MAC address. Now, who is going to send it? It's simply the target 192.168.100.1 receives this ARP request and then will generate an ARP reply. So this is the sender MAC address. So this is the MAC address I'm looking for. Okay, so I can do a right click, copy the value, and here I open the notepad and paste So this is the MAC address I'm looking for. This is the MAC address of the machine whose IP address is 192.168.100.1. This is the sender MAC address, IP address. Sorry. This is the target MAC address, which is the MAC address of my computer, and this is the target IP address or IP address of my computer. So as you notice here, now so all the information is available. So now I select again address resolution protocol. So it is highlighting all the bytes. It is highlighting okay, something like it highlights all the bytes which belong to the ARP protocol, and you can see the size of the ARP frame. This is the size of ARP frame. Now if I open this again, now you can see the hardware type field, which is 2 bytes. These 2 bits are highlighted, so this is 2 bytes. Protocol field, which is 2 bytes. Hardware size, which is 1 byte, and so on. The sender MAC address here is 6 bytes because this is the length of MAC address. So you can do this kind of analysis to find out all information relevant to the ARP frame. And you notice here ARP frame is not encapsulated inside any IP packet because it's below the IP protocol, which is actually the core of the network layer. That's why it will go directly to the data link layer, and where it is encapsulated inside an Ethernet frame. Now let me just repeat this experiment. I come here, just look at the ARP cache. We have the entry related to 192.168.100.1. So now what I need to do, I need to delete the ARP cache. So now I'm deleting the ARP cache. If I want to display, there is no such entry. Let me just restart the capture, and then I ping again. I ping the same IP address. Once I ping, you see, I'm sending the ARP request from my computer. I know my machine, it has this MAC address to the destination. Look at the destination MAC address and this protocol ARP. So again, it's searching for this. Yeah, I just want to show the following. Okay, let me just clear the ARP cache. Okay, I display there is nothing. Now I ping, I generate an ARP request, ARP reply. Now let me just ping again. I don't have a new ARP request or ARP reply. Why? Because the information is already in the ARP cache. So once the information is already in the ARP cache, no need to generate an ARP request and ARP reply. So to get an ARP reply, ARP request is generated only when the intended information is not available. And what you notice here, when I display the ARP cache, you have 2 IP addresses, you have 2 tables here. One table relates to my physical network interface card, and the second table refers to my virtual network interface card. So just look, if you know the IP address of your network interface card, of course you know it. Just look at the table beneath under that network interface card, or the table related to that network interface card. Now we have done this. I will use, for example, either ARP request or ARP reply. Well, you notice here it's sending 2 times the ARP reply. Normally it should not do that. That's why I'm going to ignore the second one. I don't know why it's doing this. Maybe the firmware has some issue. Normally it should know. That's why I'm going to ignore it. So I just skip this. So how many messages are exchanged between 2 computers when coming to resolve the MAC address? Or to find the MAC address? Normally you have these messages involved. So the third one was due to maybe a bug in the firmware of the device to which I am trace routing, or to which I am pinging. After that, I close this ARP frame and I open the Ethernet frame. This is data link layer. Now data link layer, when I open it, you find the following fields. This is the destination MAC address field. It contains a destination address, okay? And if you, when I select it, you come here, count the length. See the length is 6 bytes, so you count the number of bytes 1, 2, 3, 4, 5, 6. This is the length of MAC address. This is the source MAC address field, which contains the MAC address field of the sender. And this is the type field, which is how many bytes highlighted here. You see these are 2 bytes. It contains the code of the frame or the protocol, which is encapsulated. And you notice something here. They're using padding. They're using padding because it seems that look at the address resolution protocol. The size is 28 bytes. Since the size is 28 bytes, and we know that the minimum length of payload in Ethernet frame should be 46, so 46 minus 28 is equal to 18 bytes. So normally the padding here is equal to 18. The length of padding is 18 bytes, and this is what we see here, 18 bytes. Padding is added at the end of the type field. At the end of the type field. So between the type field and the payload. So this is padding. Padding will be added to the payload in order to bring the minimum length of the payload, the overall payload, to 46 bytes. And we can see this only in the reply. Why we cannot see it in the request? The request is the same thing. Look at the destination MAC address. What does this represent? FFF. What does this represent? What's the meaning of this destination MAC address? Look also at the source MAC address. Of course, this is the MAC address of the machine, of the sender of the ARP request, and this is a type field. So you should be able to understand or to explain what is the meaning of destination MAC address. Now let's look at the length of the address resolution protocol. Look at the length. It's 28 bytes. We know that the minimum length of payload in Ethernet frame is 46. 46 minus 28 is 18 bytes. So we don't see padding, because when you send the frame and the length of the payload is less than 46 bytes, there will be padding, but this padding is not caught by Wireshark. It cannot be captured by Wireshark because it's done at a later stage of the capture. That's why you don't see it, but you can see the padding clearly in a reply, since padding has been added by the sender. So you're receiving this ARP reply, and you can see clearly how padding has been added to the Ethernet frame. So the issue here is just to study how you can control the ARP cache. For example, now it's being populated. Some of the entries are static, so if an entry is static, it will stay there forever. Unless you reboot your computer, then it will be added. For example, these entries are added automatically by the operating system. But if you want to, you don't want your computer each time to send an ARP request, and wait for ARP reply for a specific IP address, you can add this entry. You can put a static entry here, like this. The entry of the information will always be available to your machine. No need to each time send an ARP request, wait for ARP reply. Information is already there, so it's not going to time out. It is not going to be flashed.